All righty. So once again, welcome to the HASP 2024 Q&A session. I'm just going to quickly go over the call for payloads document, and then we'll go through and maybe have, I see several individuals who have flown a couple times on HASP. I will open it up to let them give some insight for the teams, and then I will open it up to anybody to ask questions about the HASP program and about what's needed for the application. As you can see on the cover page, we have the Q&A today. We have a simple notice of intent for October 2nd. That's in the application form at the bottom, one of the last pages. It's very simple. It is not binding. We just use that to get a general count as to how many applications we think we're gonna need, and to make sure we have enough reviewers to go through everyone's applications. Then we'll have another telecon on October 13th, which is basically to address any technical issues that people have with submitting their payload application, but we can answer general questions as well. It's not a problem. Applications are going to be due October 30th. We moved that up this year, but with October 30th, that means we will start reviewing them immediately and either announce flight seats at the very end of November or at the very first week of December. That's the goal. And that way, hopefully lets you guys start building your teams now, and or at least start thinking about your teams now, and gives you the full spring semester to start working on your payload. And then we'll go hit, let me go hit the schedule real quick, just so everyone can see the schedule. So we've done these. Your applications are due October 30th. We'll make the announcement by December 8th. Then the flight season starts, basically in January, so you guys can start building your payloads. We'll have a couple documents due at the end of March and at the end of June. Both of these basically document how your payload works and how your payload design. The security documents are a necessary document that we have to provide to NASA for people getting on-base clearance. NASA has some strict clearance guidelines. We have to provide them this document 2 months in advance for any on-base clearance to NASA facilities. Normally, if you're an American citizen, a green card holder, or an individual from a non-designated foreign country, it's pretty simple. Designated foreign countries, and there's a link in this document, are links that the U.S. State Department does not have, considers countries of ill repute, I guess. I don't know. They basically don't have consulates, or they have certain issues with these companies. China's one, Iran is one. There's a couple others. I'm somewhat surprised Russia's not, but that falls with the space station. I don't think they can. So there's a couple countries there. Those individuals, unfortunately, will not be allowed on base. NASA has some super strict restrictions for them, and we cannot meet those restrictions. At the end of July, we will have a student payload integration session at CSPF. Basically, your completed payload will travel to CSPF's home base in Palestine, Texas. We will load you guys up into a thermovac chamber with HASP and pretend like it's a flight. We will take you down to about -50°C and sit there and make sure your payload operates properly in the cold, and then take you back up to probably about 50°C and make sure that your payload can function properly in the sun, or in the heat. If you're directly in the path of the sun during float, you can get pretty warm. So we just want to make sure your payloads are able to experience both extremes. After that, you guys, if you successfully pass, you get declared flight ready. Everyone goes back home. About a month later, we move to Fort Sumner, New Mexico, which is where the launch happens. And usually we get there the last week of August. We declare ourselves flight ready and has CSBF declare us flight ready very beginning of September. And we try to have a flight by Labor Day. That's usually the schedule. It could slip a little due to weather. This year we had a lot of payloads trying to do the same date, so there was some shuffling going on. But normally around Labor Day is when we shoot for being flight ready. We fly within a few days of that target normally. Our average flight time or float time is about a little over 14 hours, if I remember the number right. So we'll be up at float anywhere from 10 to 20. That is our minimum success is 10, and our desired is 20. So normally we're somewhere in that range. 14 is our average. So you get a pretty good amount of float time to run your experiment. It lands. It usually takes 2 to 3 days for the recovery team to get there, pack the payload up, put it back in the truck, and bring it back to us. After we receive the payloads, we will box them back up, or if you are on site, you can box your own payload back up and ship it back to your locations. And then finally, there's the final science report that is due in early December 2024 to close out the 2024 session. Basically, there are some hazards that are banned on HASP. We have included the most recent hazard list. We have added pressure vessels back to an approved hazard. You just have to meet certain restrictions. We are trying to get all of the information. I'll show you in a second what I mean. But basically, here's all the hazards list that we have. Explicitly banned are very strong magnets, anything over 1 Gauss outside of your payload. We're not going to allow intentionally dropped components at all. Liquid chemicals, we don't want spills. They become a headache, and they are a serious problem with the hazard documentation team. So those are out. Cryogenic materials, the same. Radioactive materials, we're not allowed. That's a whole massive problem. Pyrotechnics, UV light. By UV light, we mean UV light outside of the payload. If it's completely enclosed and you document that it's completely enclosed, that's a different thing. But any UV light outside of the payload is not allowed. Biological samples are currently banned. Rechargeable batteries are currently banned. Non-rechargeable batteries are fine. You still need to provide some documentation, which is in the hazard list at the bottom of the CFP. And high-intensity light sources. Again, we have lasers up above that are allowed. The high-intensity light sources are things that are not encapsulated or completely enclosed in your payload. They're a hazard. You could blind somebody if it's just beaming out and no one's looking for it. Recovery team could get blinded or have some other problems. So high intensity light sources are banned as well. Lasers are approved. And so basically that's the major hazard list for HASP. Anything else? If you have any other ideas, put in your payload and we'll let you know. But these are the ones that we've documented. Balloon Program Office at Wallops has documented as high hazard materials. I'm going to go up and give you basically a general introduction. This will be the 18th year of the HASP payload. We have flown 17 times starting in 2006. 1 year we had to stand down because of a mishap incident with the launch system. And so the next year we actually flew HASP twice in 7 days. So we actually launched it, landed, recovered it, brought it back, refurbed it, put new payloads on it, and launched it again. So HASP is a pretty robust system, and it's built to take a little beating and not have any major issues. And then of course we missed COVID year as well, like everybody. So this is the HASP vehicle. Let me see if I can launch vehicle. So as you can see, we have slots for 4 large payloads and then 8 small payloads that go around it in a ring. And we have the specs for each payload system right here. The small payloads are 3 kilograms. They're allowed to be 30 centimeters in height. They must meet a they have a width and length restriction. And when you get your payload plate, it's actually designed, and there's you can see the payload plates in this document to see what we mean. Small payload plates will have a serial interface of 1200 baud. It's an RS-232 connection, protocol connection, and you'll have a DB9 on your plate that you connect to. We allow, you guys have uplink commands. You're going to have a 30-volt power system and a maximum of 0.5 amps, so half an amp. So you will also have some discretes. So every payload gets an on-off discrete. That's fine. Some of the smalls actually have 2 additional ones. So if you're designing something for, say, opening a shutter, and it's a mission critical design, you could have a serial command that you send up to open, or you could have a discrete command that just sends a signal that opens, opens your shutter and stuff like that. That helps having 2 paths for mission critical systems. The large payload, the 4 larges, we allow a bigger footprint. So that is a 20 kilogram payload. He again is allowed for 30 centimeters high, but he's got a bigger ground footprint. And you can see from the payload plates what I mean by that. They have a faster serial rate of 4800 baud, and they have a higher supplied current rate. So their higher supplied current is 2.5 amps at 30 volts. And again, all larges have the 2 general discretes, power on and power off, and then they have 4 additionals that can be used if you need. Let me see if I can find the payload plates for you guys. There you go. So these are the 2 payload plate sizes. Obviously, this is the small. This black square is the actual footprint for the payload. For smalls, we allow 30 centimeters above the plate and 30 centimeters below the plate. You can go in either direction. For the larges, obviously, it is 30 centimeters above the plate only. You can't extend into the HASP frame, unfortunately. Well, fortunately, because they're batteries underneath here and flight systems underneath this side. So that would be bad if you were encroaching on those. Here's a couple plots of a general HASP flight. As you can see, with a typical sounding balloon, small payload, it goes up, it pops, comes back down, or you terminate 1 and 2. For a HASP flight vehicle, you go, you start your ascent. Ascent takes about 2 hours, and then you stay at float. Our float minimum is 110,000 feet, and our desireds are over 120. So we try to get you guys pretty high. Float, and then this would be terminate. It comes down the parachute and lands normally pretty softly without much damage. This year we had a little ding, but for the most part, everything comes back in one piece. Here's a couple temperature profiles. As you can see, if you're following this red line, this was a temperature sensor that was just sitting on top of a payload. So he got up to about 40 C and actually down to about minus 80 right before termination. When it gets dark, it gets cold very quickly too. And then we had an ambient outside with just a temperature sensor that wasn't facing upwards or facing any particular direction. It was just kind of tucked around the side. And you can see it's a little bit less harsh, but it can still get pretty cold. yeah, so going through, let's go here. So we have um, we have an integration and commanding sheet that we will discuss later as the system goes, but basically there's a method for you guys providing commands to the flight system, and the flight system will then upload any commands to you. So you have full commanding of your payload if you so choose. We generally recommend that teams have some commanding and also some data link down. If you fly a system that records data only on the payload, then you have no idea if your payload is operating properly during the flight. So we always recommend that you telemeter at least something down with timestamps, because that way you're able to quickly check if your payload's working well or if something's going wrong. You don't have to telemeter all of your data down, but you want to telemeter at least housekeeping information. My system's working fine. I get this timestamp. The temperatures are X. That way you can help you diagnose if your system is having a problem. You will be at vacuum at 120,000 feet. You're somewhere around 8 millibar. So your system will be exposed to an extreme vacuum. So you want to be prepared for that. Hazards we've gone through. We've done the anticipated schedule, which is fantastic. Deliverables. So each month, the teams, accepted teams, are required to provide a monthly status report. It's a very simple form. It's actually on the website right now. But basically, it's goals accomplished this month, issues that you've run into this month, what you plan on doing for next month, and then a student demographic form, which may be changing shortly with the way we need to collect that information. But for right now, it's on that document, monthly status. It's really simple, but it's a way of us keeping tabs on the progress of your payload. In addition, we have a monthly video conference where we all get together, we present anything that's going on for that month, anything teams need to be aware of, what's coming up in the schedule. We review the monthly status reports and then answer any questions that teams may have or any issues that they've run into for that month. The PSIP, a payload specification integration plan. So those are two documents that basically it's one document. You provide us one version. We will comment on it, make comments, ask you to make changes, ask you to add information, and then the final one is your completed document. That document basically details out how your payload is built, how your payload functions. So you want to be fairly specific in there. Also in the PSIP is some hazard documentation. If you are flying a hazard, we have to provide hazard information to the NASA safety team. They have to review those hazard information, and then they have ultimate approval of whether or not that payload's hazard is cleared. So in your application, if you know your hazards are ready and you can answer all those questions, and we'll look at the appendix in a second, I'll show you what I'm talking about. But if you can answer it in your application, fantastic. That gets them a jump start. The preliminary PSIP is the final time where we can provide that hazard information to NASA safety. That preliminary PSIP is due at the end of March. That gives NASA safety time to review that documentation and give a final yes, no in mid-April. Normally, if you can fill out that form, those forms, you are perfectly approved. If you can't fill out those forms or run into other issues and can't address those topics with NASA safety, then there's a whole lot of back and forth that goes on and a whole lot of documentation, which is something we're trying to avoid so it doesn't chew up a lot of your payload time. The safety clearance stuff, security clearance stuff, we've already gone over. Green card citizens are treated exactly the same as U.S. citizens. So if you have a green card or naturalized citizen, you are fine. Flight ready. So we want a flight ready payload for integration, or at least a almost complete flight ready payload for the beginning of integration. And at the end of that week, we hope every team's payload is declared flight ready. If it is not, you do have some time between between integration and flight to repair. But the goal is for everyone to not have to touch their payload for that month of August. The payload integration certificate. So that is something that we do. That is not a document that you have to provide to us. We do this during integration. As we go through the integration test, we have certain markers that all teams have to meet. And as we go through the test, we'll be marking these off. And at the end of integration, we then give you a payload approved and payload cleared for flight, or payload has issues, and we discuss how to address those issues. The FLOP. So the FLOP is a flight operations plan. So this is a shorter document than the PSIP, but basically the FLOP details how to run your payload, how to mount it, how to set it up for flight, how to run it, commands and everything, and then how you want us to ship it back to you. Since no one is required to be on the flight line, and teams are allowed to remotely monitor and command their payload, no one needs to be on the site. So it could potentially be just the HASP management, myself, Aaron Ryan, Dr. Guzik, and maybe a couple other people would be on site. So we need to know how to operate your payload in that situation. And generally, it's explain it to me like I'm a 5-year-old, very, very simple. Pull lens cap, set this stuff up, but we want that FLOP to tell us how to run your payload just in case you aren't available. Finally, the final report, final flight science report, that's due in December of every year. Inside that report, we basically want a full assessment of how your payload operated for the year, and how did you meet your science goals, what you plan on doing. If you have a failure, your failure analysis, and how you would plan on fixing it. And demographics. NASA is very big on demographics. How many people took this? How many people participated? This type of people, male, female, other. They want to track all that stuff. They love it, so they can know what to reach for in the future. And so we are required to track it for our documentation. We have a template for that guy. And there is a template for the demographics form. So all of that is packaged in that template, but it is a very important feature of your science report. The final one is this balloon program documentation. So as I said, with some hazards, NASA safety may require additional documentation, and that's where this section comes in. If you've answered all the questions in the appendix and they don't have any additional comments, then we don't have to worry about this. Special requests. So we have set up certain restrictions on the payload size, payload weight, communication limits, speed of telemetry, stuff like that for each payload set. If your experiment goes outside of the bounds of those restrictions, you can request a waiver. That request needs to be scientifically justified, not just, if we were a little bit bigger, we could collect more data. That's not a valid reason. You would need to justify why you needed to expand out of that thing. You need a certain focal length for a camera. You need something else. Those can be accepted. One of the issues, particularly for the height of a payload, is that the entire HASP frame with payloads gets mounted in the thermal vac chamber at CSBF. That is a tight fit. So going above that 30 centimeters, I think there's probably maybe 5 to 10 more centimeters, maybe a little more than that, above that, or we hit the ceiling of the thermal vac chamber. So height restrictions are pretty tight. We can discuss, but there's not a whole lot of play there that we can work with. The monthly Q&As, or the Q&A conference, which is what we're in now. Here's the link for that stuff. Here's the application preparation. This details what we'll need in the application. We need a cover sheet. And you guys should have the template, and we can open that up in a minute. You need a cover sheet. You need to describe your payload. You need to include the payload specifications, preliminary drawings. Preliminary drawings we want need dimensions and units. We have a lot of teams that will submit pictures and drawings that have no units anywhere, so we can't assess whether or not your payload is too big or has other issues. So when you provide preliminary drawings, we need dimensions and units on those drawings. Finally is the hazard documentation, and we'll go look at that in a minute. And this details how to submit it, a Word document. You can submit it as a PDF document too. It's not a problem. Submissions, they're all due by end of day, October 30th. Mail it to this HASP at LSU email address. That is an address that everyone here can access. So we'll get it, or you can alternately send a hard copy. You don't need to. If you email it, we do not need a hard copy. We currently do not provide financial support to payload teams. So payload teams need to raise their own money, however you need to do it. Travel, there's a little bit of travel, particularly to CSBF's integration. That trip is in some sense way more important than the trip to the flight line. Although flight line, you can occasionally get a pretty cool view of a balloon launch if you happen to be lucky enough to get it. But integration is where teams do their final amount of work. They actually go through the stress test. It can be pretty intensive, but it can be a really good week of work for teams that arrive. So we do not provide funding for that currently. Who knows about the future, but for right now, HASP is only a flight seat with no funding. Foreign travel documentation. We've been asked about this before. We cannot provide letters to the embassy or any form of visa documentation or take official, I don't know the official word, but official ownership of incoming foreign students. That is not something that our legal team is happy doing, and so we cannot participate in that. If you need to provide documentation to a foreign institution, the HASP letter of acceptance, the CFP, and your application can be used for that information. We just cannot write anything additional to that. There is a new addition to the safety security plan that happens for any teams with foreign nationals. It requires a letter from the primary institution, basically stating that primary institution takes authority over the members of their team, not NASA or anybody else. There is a letter posted to the website already, so you could just copy it and change the important information. Private company support. We encourage teams to get sponsors and would love for private companies to do that, but we are not a testing system for private companies. We are not going to fly a T-Mobile phone with T-Mobile written all across it so they could get any form of advertising from this. We're not, that's not allowed. We're also not allowing, say, private companies to use a HASP flight as a engineering test or proof of testing for their devices. We are happy to have those test devices. We have done it multiple times, but we're not in the form of providing commercial support for people to test, to verify their equipment. We are happy to say that this flew on HASP and you experienced these conditions, but it's not some form of official certification. As I said, here's the NOI. It's really simple. It's not a problem. You just name, institution, your student leader, your team leader, your faculty leader, and then just if it's a multi-institutional proposal, we'd like to have a primary institution, and you can list everyone down here, but that's just preference. It's a little easier for the paperwork. Security clearance, basically here's all the rules for the security clearance system. I've added this table to the CFP to kind of make it a little clearer on how you define the classification. US birth, US citizenship, no problem. Non-designated birth, US green card, citizenship, permanent resident, not a problem. A designated country, but with US citizenship or green card or permanent resident status, you are still treated as a US national, so you are cleared at the moment. If you are non-designated born, non-designated country, then you're a foreign non-designated, and then this rule apply. For the last three, if foreign born but a designated citizenship, you are unfortunately considered a designated individual, which comes here, and then the same for the other two options. Designated individuals are not allowed on NASA property under our rules. Hazards, so this just goes into the documentation for the hazards, and in the appendix we have everything that NASA safety requests to analyze and study your potential flight hazards. Radio frequencies, you basically just need the model of the transmitter. Are you doing a ground or flight transmitter? Basically just very, very simple answers that should be included with whatever transmission system you have. One thing to note, range between 425 and 435 megahertz is explicitly banned because that is the range that CSBF uses to operate their electronics on flight. And we do not want any interference with that. We would certainly hate for someone to accidentally trigger the terminate sequence. High voltage, basically a couple simple questions. This is pretty good. If your high voltage is fully encapsulated inside of your payload, that is fantastic. That's one less thing they have to worry about because they won't be sticking their hands near your payload and encountering a nice shock. Lasers, same thing. Basically, you need to answer all these questions. If your laser is fully encapsulated, that's great. You just want to make sure that you provide NASA safety with as much information as possible. Onboard batteries, again, rechargeable batteries become a problem because of improper handling, so those are banned. But if you are using normal batteries, anything purchased off the shelf will almost always be immediately approved without any further discussion. But including your battery discussion here, if you have it, makes it even easier. You do need to include that UL certification. But yeah, basically answering these questions, and it's pretty simple. Notice the battery modifications. You are not allowed to modify the batteries in any way. You can, add them into a carrier that has like multiple AA's, for instance, that gives you a lot of, but actually physically modifying the structure of the battery is not allowed. Pressure vessels, we have brought this back this year. It was actually banned last year. But there's some detailed documentation that needs to be included when you're doing pressure vessels, including FEA analysis of your pressure vessel and documentation of all the components inside your pressure system. It's a good amount of information. So if you intend to do a pressure vessel, you want to get started early trying to address a lot of these questions. I worked with NASA Safety's pressure guy for a good bit, trying to pare these restrictions down and trying to get them all included early, so no one's getting questions in May or June as to the nature of your pressure vessel, because that's way too late and cause a lot of problems. So if you could address all of these bullet points, then they won't have any issues approving your payload, or shouldn't have any issues going through and approving your payload. So that is basically the call for proposal. I think I'm going to stop here because I've been talking for a while, and open it up to any former flight teams that want to ask any questions, and then we'll get to the team questions as well. Go ahead, Teresa.
I just want to check to see if we're still able to bring students who are not 18, because I have some high school students that interact with my college students.
I will clarify that, but we have allowed that in the past, and no one has explicitly stated to me that we can't do that anymore.
Okay.
We have had, as you've seen, we've even had high school students come and do this program, and no one has expressed an issue with that yet. So I would say you're still good.
Good, thank you.
Would you like to give a recap of your experiences with HASP, or you or Dr. Patel?
Oh yeah. But let's Teresa first.
It doesn't matter, Dr. Patel, either way. So I am at a community college, and we sometimes have some high school students that hear what we're doing and interact with us. And sometimes our experiments work and sometimes they don't. But in either case, it's really the process leading up to flight where students learn the most. And one of the things that I always have my students do is make sure they keep a digital portfolio of everything that they work on. I have them take pictures of, this worked. And I also have them take pictures of this did not work. This was my fix. Now it works. So that when they apply for internships, or they apply to transfer, or even later when they apply to some of the places I now have students like Millennium Space, Tesla, they can show what they were able to do with this project, and it gets them in the door.
Dr. Patel, thank you, Teresa.
Yeah, so the HASP is very good opportunity to test your science concepts and making your engineering payload. And I'm doing since last 2008 every year. So my suggestion is that particularly those who are doing first time, make your idea very clear and do all the work, particularly to complete the payload before coming to Texas, Palestine. Do not come with a circuit board and do the soldering work there. You will not able to finish. You may be nervous also at the last minute. And whenever you buy any component or circuit board, make a one backup also. So in case something happened to your component failure or circuit board failure, you can immediately replace that one. And when you buy the component, make sure that the temperature tolerance should be like a space grade. So it can withstand very low temperature and high temperature. So do not buy the commercial grade component. So this is very good opportunity to learn whatever you do in a lab. You can perform in a Texas, you can to perform in a New Mexico, you can to perform in a stratosphere. So when you got your data coming from the stratosphere, you will be so happy to see your data is progressing. You can also change the command, uplink command, and you can control your payload, and you can do so many things. I have two questions, Doug. One is our UNF team is preparing a new payload this year for 2024. And we want to compare with our previous hardware structure. So do we need a two application, or in a one application, we can propose both together?
You would need two seats, right? You would need
Yes. Yeah.
then propose two applications and just document that they're tying together.
So, so our request is that if seat available, we'll go for two. If
Yes.
seat is not available, then we'll go for any one.
Okay.
The new one.
And you could also document that if especially for a small, it's possible that we could place you in like a second payload in like a piggyback situation. Yeah. off on the launch.
That's fine. That's
fine. So just document that it would be nice to have two in your proposal, and you want to compare and just keep them separate.
Yeah.
But just make sure it's clear that one of them is primary. If we can only support one, this is the one that you want, and the second is your whichever one is the secondary goal.
Okay. And one more suggestion this time. Like my team is also working with NEBP project, Solar Eclipse project, and we did two launch recently. Now students are asking me question, how big valve, control valve, how they control the telemetry, how they, compared to Solar Eclipse, how they do the HASP doing, So if someone can give a popular talk somewhere in any one Friday with a PowerPoint slide that how big the balloon, how much gas can be inflated, what rate we are inflating, right? What's the valve size, how they control the altitude, how they cut off the system, how big the parachute, how they tie the parachute with the payload, something like that.
Sure.
To the track. We
should be able to do that. Yeah, that's not a problem.
Something like a popular talk so everybody can have idea, the newcomer.
Okay. Yeah, that's a good idea.
Yeah.
It's another thing I need to record. Okay, thank you.
Thank you.
Chris, do you want to add anything further? I noticed you're down there.
Yeah, thanks. I'm a camera turner offer. Sorry.
Yeah, no problem.
I think two things. Be sure to take the hot temperature case seriously. The most of the payloads that I see fail because of heat, not of cold. And also remember, you're not going to get the cold until the end. Right. So if your flight dies because it got too hot 3 hours into the flight, it doesn't matter if it can survive cold. And I guess the second thing is I really encourage you to take seriously the documentation and do a good job at it. Because in the end, when you go to a job interview and the hiring manager asks you, well, what did you do? If you can hand them some of that documentation and say, here's what I did, look, it's all written down, and they can pass that around to the engineers in the group. I've had students get hired at major aerospace companies solely off what they did in HASP. And if it's not written down, you might as well have not done it.
Greg loves to discuss that with people going in for entry-level positions and showing that documentation and having the hiring person say, oh, you're not going for this. You want this further advanced role because you've already been exposed to this type of environment. So if you take it seriously, it can be very productive and very beneficial. Aaron.
Yes, and I would just add on to what Chris said, especially those temperature concerns. that is specifically microprocessors and power components, right? Because a lot of those components that you buy off of the shelf are designed to operate in atmospheric conditions where they have a nice heat sink and a fan to move air over it and remove heat from the component. And that is not something that is going to work at all when the pressure is sub 10 millibar and there is basically no air to dump the heat into. So typically, things like normal linear regulators are gonna not be able to carry the normal rating that they're listed for because they're just gonna get too hot. So that's why you want to use something like a DC to DC converter, either a booster buck converter, and then you want to use some sort of lower power microprocessor that can basically handle passively dumping its heat, and maybe you have a block of aluminum that you run to like one of your outer walls or something like that.
You'll also find that no company is going to guarantee that their product works in this environment.
Right. Yes.
So
the vast majority of companies, even if they have high altitude ratings, those are going to be like 5,000 feet or 10,000 feet, maybe, like where they're saying, no, this will work on mountains. We have no experience with, in a aerospace environment. Or maybe the best you'll get is somebody who works on like avionics plane equipment, and even then that's a completely different situation. So
if you can, I recommend you try to test yourself components that you're not sure of or somebody else hasn't flown before. We turned a large canning pressure cooker in our lab into our own little thermal vac chamber for a few $100s. I'm happy to provide pictures and sorted directions of how you do that. If your university has a machine shop where they are capable of welding or modifying the lid, you can make your own thermal vac chamber for a few $100s.
Hey, Chris, that will be a good idea if you can provide that information.
Do we still have like the HASP mailing list or, places I could send it? Because I can take some pictures.
I will send you email. Yeah, thank you.
Yeah, what we did is we just took the pressure cooker, had the machine shop machine 2 holes in the top, and they welded on a vacuum fitting and a flange for a hermetic electrical connector.
Yeah.
And then you fill the gasket of the pressure cooker with RTV.
No, I have 3 big vacuum system for my thin film deposition, but I like the pressure cooker ideas, so I want to try that one also.
Chris, you could also send it to HASP at LSU and I could disseminate it as well.
Okay, yeah, I can take some pictures. And then the way we do the thermal part of the vac is we get a 5-gallon bucket heater from McMaster Carr and put it around the outside and stick it into a big styrofoam cooler for heat, and then put dry ice into the styrofoam cooler to get cold.
Yep. All right, I think I've talked a lot, so I want to open it up to the students so you guys can ask questions before.
Actually, Doug, let me highlight one. So one more, if you have moving parts, mechanical parts.
Yes.
The typical lubrication schemes are, like thermal are on the ground are petroleum-based greases, and that's generally not what you want to use in a high vacuum or high and low temperature environment. Either it'll get hot and all the grease will melt out of your bearings, or it'll get cold and it'll freeze up and seize. So if you're looking at that sort of thing, just probably some sort of dry lubricant is what you're going to want to work at. There are a number of sort of space directed ones that we've seen, but also maybe something like colloidal graphite will maybe work, that sort of thing. Neolube is commercial brand name, I think, for that stuff.
Thank you. Yeah. Dicronite is another one we've used. So, okay. I want to open it up to make sure students get any questions that they have. Please fire away.
Hi there. I had some questions about using LoRa. I
Laura.
know the RF. Yes, I know the
Okay.
RF said it's under an appendix. Is that encouraged or discouraged or okay or not okay?
No, we have teams use LoRa. We've had several in the past few years. You just want to document it. Putting RF systems on HASP is okay. It's just there are a lot of RF systems on HASP. So you want to make sure that you're outside of the range where you would be interfering with anybody else. That's one of the reasons why we want you to document as early as possible your hazards. Like if you know what range you want to operate in right now, put it in the application. You know, we intend to use this frequency range, blah, 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 you know, this width, and put it in there, because that just makes it easier for us to document it and make sure that there shouldn't be any issues with operating at that frequency.
Also, if you have RF, work under the assumption that HASP is going to interfere with you, because it is.
Yeah.
And any RF that you're using on your payload needs to be covered by your licensing, whether it's an over the an off-the-shelf thing where you don't need a special license, or your team has a licensed ham operator. You know, we do not provide nor does CSBF any of the FCC licensing for any transmitters you're going to
we are working over that. We are getting the license.
Yeah. Did that answer your question, Dustin?
Yes, it did. We have a comms professor that would really like to see us implement LoRa for a live feed as well. So
yeah.
I just wanted to touch base on that.
We had a team this year doing some LoRa video feed stuff. They ran into other issues like overheating with their transmitter, but yeah, we had a team do it this year. We've had some of the NEBP stuff on our payloads multiple times using their LoRa transmissions, or even their Iridium stuff. So that is more than very accepted.
If you're going to do something like that, you'd probably want to put some consideration into your antenna placement and where your payload seat is going to be, so that the majority of the HASP frame is a big hunk of aluminum, and it's going to rotate slowly throughout the flight. So just be aware. And if you are wanting, for example, an antenna in a specific position that is not on your plate, that is sort of the thing where you would apply for an exception. And assuming it's justified and it doesn't interfere with other payloads or the general operation, that's the sort of thing where we would be willing to accommodate. So
yeah. Normally it's not a problem, but
yeah.
Any other? Oh, go ahead, Dustin.
Do we know any frequencies that are specifically going to be a no-go right now?
Like I said, that 425 to 435 is absolutely a no-go, period. There are some higher frequencies than that. I can't remember the EVTM frequencies.
We were at 1081 and I can't remember the other.
Yeah. So
I got it in my notes right here. 2361.5 were the two EVTM.
So there are a couple, but again, if you document it, then we could work with you on changing it as well, which is what we had to do with one of the teams this year. Was they were just asking for too much and too large of a range, and so we worked with them on pinning it down. So yeah.
The other sort of complication with that is we are relatively close to white sands. So even if it's something that you would normally say be able to operate within one of the ham bands easily, because we are basically, there's a big giant box around White Sands where there are extra RF ham radio restrictions, and we will be inside of that the entire time. So
any other questions? Please fire away. We have plenty. Oh, Joyce.
Yes, I have to run to another meeting, so I just want to say, as I put in the chat, thank you for everybody's participation. It's so awesome to see HASP each year, and Doug, Aaron, Greg, the whole team is fabulous to work with, and your dedication is pretty admirable. So Wallops is pleased to work this again this year to make success for all these teams. So thank you.
Thank you very much.
Joyce is fabulous too.
Oh, I'm glad I heard that before I had to jump off.
There you go.
Actually, so we posted Doug showed the links to the videos, and we posted the links. I posted that in the chat. So if you have some sort of visual verification that you want, that is also something to include in your payload application. You know, the video streams that we have are live during the flight. So, you know, if you have something that's moving around, or if you have some indicator lights you want to see, that's possible. You just need to document that, because we do not have complete coverage. So we will try and give teams priority to be in the line of sight if they have something they want to be able to see on those video streams.
My goal is to have near complete coverage, but I don't think we'll get everybody covered, every single payload. So yeah, if you want to be in the line of the cameras, make that request. You know,
So Doug, this time the camera was little different than the last year, right?
Yes, and next year will be different again. This
Last year was little, I think, believe that tele type camera, so we can see the horizon line, nice blue color.
And we're gonna go back to a form of that camera this year. We had some issues at the last minute with that barrel camera that we normally use facing your payload. It wasn't available, let's just say. So
it sounds like CSBF is phasing out their camera platform. So we do, Leslie, we do typically fly a downward facing camera. That was what one of those streams is. Typically that's a lower priority just because it's less interesting. So if we were, say, for some reason, for power or space or something, we were only able to fly 2 cameras, that's usually the one we would cut. But if you have a specific desire for downward facing video that is part of your science, document that, and obviously we will then reevaluate. So
no, downward we don't need it. That's fine.
We do it because occasionally it's a pretty cool shot, but
and Leslie specifically asked about that in the chat. That's why I brought that up.
But I do remember when we do first time 2008, 9, and 10, there was one nice camera which can move upward direction.
Yeah.
When they deploy the parachute, we can see entire parachute picture also.
Yeah, that camera went away. That was the CosmoCam system, and they stopped using that a while ago. And most of our cameras now have just been rigid mounted. I've thought about, and with the new communication system, this EVTM system, it would then allow me to bring back some form of pan tilt zoom camera. But until we have that working perfectly, we haven't thought about bringing a system like that back. We need an optical facing.
Yes, Leslie, definitely request that downward facing camera if that's something that would affect your science. Yeah. So typically, like I said, typically that's one of the less interesting feeds and nobody really needs that data. But yeah.
So Ian, does the payload generally land safely or do we have to? So I would, hold on, let me find a picture here.
Doug, do you have picture of this time
Of some of the damage?
recovery team picture?
Oh, temperature? Yeah, I'll get that for you. So as you see HASP up here, normally what happens is HASP lands pretty straight up and down. This ballast hopper gets jammed up into this, but that's not a big deal. And HASP may normally just either stay straight up or tip 90 degrees and land on its side. These booms here are fiberglass booms. They're designed to break, basically, so you don't get crushed. Normally we'll have a bunch of booms broken, but we have only had, out of the 17 years, we have only really had maybe 4 payloads take some significant damage. And even when I say significant, it's not that bad. Like, let me see if I can find a picture of this year's landing. Because we did take some damage this year, but it wasn't terrible. Here we go. Through the screen. So this payload was on the top of HASP, and when HASP fell, I think one of the beams was jammed into it. And so as you can see, their top lid, which is just thin sheet metal, peeled up. Oops. Peeled up and took a little exterior shell damage, but none of their cameras were broken. Nothing on the inside was damaged. Just you had a little bit of a facial makeover. Everything else functioned right for them that we know of. It just took a little bit of bend damage, and HASP took a little bit of see how these beams break. They're made to do that on purpose. So when it falls, those beams break and snap up, or they actually take a little bit of shock absorption and slows the fall. So generally it's a fairly soft landing generally. There have been cases where the parachute doesn't terminate properly, and so HASP will get dragged, or if you smack into the side of a mountain. But normally they do a very good job of trying to predict termination, and we can get a pretty decent landing that's relatively soft. So if you have a good external structure, your internal components should not have a problem.
The design stress, largest shock is usually what you consider is an 8G vertical shock. That is basically the parachute opening upon terminate. And then there's smaller, horizontal or diagonal, but yeah, like 8G vertical is usually sort of the design maximum shock.
I have to get going here, but I wanted to say one other thing to the students that are on this call. Listen to Doug and Aaron and everyone on the team when they say use the uplink and the downlink. 1 year we used the uplink to fix our payload during flight. It was not functioning properly, and we were able to uplink new commands and get it to work. If you wait until you get the little micro SD card back, it's too late. The flight's over. And so if you have at least some of your data coming down during flight, and the ability to send up commands to fix things. And that can save you, and you will actually have a productive flight. So take the time, it's worth the time to figure out the uplink and downlink, because that can save your project instead of getting the micro SD card back with nothing after all that work.
Yeah.
But I gotta go.
Bye.
See you all.
Thanks, Teresa. Yeah, guys, if you have to go ahead. I know we're over, but I am happy to answer any more questions. And
how is Dr. Guzik?
He is recovering. He's doing better, but yeah, he's got a little bit of a slow recovery for a little while.
So convey my best wishes for his speedy recovery.
I sure will. Do you guys have any more questions? Please feel free to ask. Oh, I heard a pop, but that was it.
Sorry, that may have been my chair.
Oh, okay. All right, guys. Well, if y'all don't have any more questions, we have another telecon in 3 weeks. Please feel free to join. If not, send us an email. We can answer email.
So, Doug, our team will not join on 13 October.
Okay.
Because we'll be in San Antonio for solar eclipse.
Okay. Yeah. Well, good luck.
Yeah, thank you.
Absolutely. All right, everybody. Have a good week. Bye.